We now know that one-point perspective is used mostly for straight-on looking points of view. If you want to turn the camera to be non-perpendicular to the rest of the scene, however, you need to introduce a new vanishing point to prevent awkward distortion of objects. This is what two-point perspective is all about. As previously mentioned, each vanishing point in your scene relates to one of three dimensions that makes up the visible sides of the objects you're drawing. Since one-point perspective has only one vanishing point to recede the depth dimension of objects, adding another vanishing point will cause another of the two remaining dimensions to recede as well, leaving only one dimension left with straight parallel lines. Typically, the vertical lines of all of your objects will be the dimension left parallel. Just like before, the second vanishing point in two-point perspective will always be placed on the horizon line. However, the distance between these two vanishing points is key to drawing proper-looking perspective. As you can see, when the vanishing points are placed too close together, there's very little room between them for objects to be drawn at a decent scale without appearing distorted. When the vanishing points are placed much farther apart, objects will appear more flat with limited recession of depth. So what's going on here? How do you find the proper distance between these two vanishing points? The answer is a little complicated, but I think we can work it out. This is all related to something called field of view. Anything that can see or record images with a lens has a particular field of view that allows it to see more or less of the environment surrounding it. If you've ever used a camera with a zoom lens, zooming in effectively changes its field of view from wide to narrow. The narrower a field of view gets, the farther apart the vanishing points get in a scene. The wider a field of view, the closer together they get. Human eyesight has an approximate field of view of 135 degrees from side to side. This is important to remember. Since you've experienced that field of view throughout your entire life, it's a good reference point to use as we go forward. First, we have to take a moment to understand the following. The horizon line is not actually a straight line, it's a circle. It only looks like a line instead of a circle in your drawing because the view of your scene is placed exactly in the center of it. As we turn in place, we continue to see more of the horizon line around us. This is why the horizon line never recedes into the distance. It only surrounds us. Next, we have to consider how the two vanishing points in your scene relate to this horizon line circle surrounding your viewpoint. Did you know that there are actually at least 4 vanishing points on the horizon line at any given one time? If we look at the horizon line from above and turn it into a compass, each vanishing point will be located at north, east, west, and south. Since you're standing at the center of this compass, you'll encounter a vanishing point for every 90 degrees that you turn in place. And since you have a limited field of view of 135 degrees, you can only ever see a maximum of 2 vanishing points at any one time. The fact that the vanishing points are all 90 degrees from each other is a very important detail. This means that no matter where you place the 2 vanishing points within your scene, they will always exist at 90 degrees apart from each other on the horizon line, no matter how close together or far apart you put them. What the proximity of these 2 points will affect, however, is the field of view of your scene. Remember how I said that when vanishing points are closer together, the field of view is wider? And when they're farther apart, the view narrows? Now you know why. The vanishing points are locked in their physical distance from each other. So based on that knowledge, we can infer the field of view on the scene based on how close together or far apart the points appear. But what about their actual positions inside or outside of the picture plane? Well, there's one last major aspect to cover, something called the vertical center line. This is a helpful tool for planning two-point perspective. Basically, what it is a marker for the location of the center of the viewpoint. In almost all cases, it should exist at the exact center of the picture plane, just as it always does for your own vision or for uncropped photos. It can be moved off-center, but this is effectively the same as cropping your picture plane inward, so the approach of utilizing the vertical center line is the same regardless as we move forward. The vertical center line can help you properly place vanishing points. Since we know the vanishing points are always 90 degrees from each other, all we have to do is create a single right angle that intersects the horizon line at 2 points, where its corner pivots on the vertical center line. Let's say we want to draw a scene that is more like one-point perspective with just a hint of 2-point depth. One vanishing point will be somewhere near the center of the picture plane, but how far away should the second point be? Well, this is where that right angle comes in. One side of the angle should pass through the first vanishing point to the vertical center line. The second side will intersect with the horizon line. This intersection is exactly where the second vanishing point will exist. Note that you have control over how large this right angle is. A smaller right angle will yield two vanishing points that are much closer together, a wide-angle view, while a larger right angle will yield far apart vanishing points, a more zoomed-in view. A good rule of thumb here is that if the entire right angle is located within the picture plane, your scene will contain highly distorted perspective from being too wide-angle. Typically, scaling the right angle so its corner pivot is located outside of the picture plane is a surefire way to create normal fields of view that will look good and be easy to draw. Notice that as a vanishing point gets closer and closer to the vertical center line, the other vanishing point gets farther and farther away to either side. This is normal. Remember that these vanishing points are like the directions on a compass. As one vanishing point hits the vertical center line, let's say north, the other vanishing points are perfectly to your side at east and west. You can't draw your right angle to intersect with the horizon line since north is dead ahead. This is why one-point perspective only has one point. The other points at east and west are parallel to your scene and cannot project depth. I really hope this makes sense and can help you out. If you are still confused by how some of this works, please feel free to ask any questions in the Q&A section of this class. Don't be surprised if you find yourself drawing with two-point perspective more often. It's very practical to use in just about any level view scene. Most photos you see most likely can be redrawn with two-point perspective just fine. It's not until we start to look up or down that an extra vanishing point is required. But since we look forward most of the time, that third vanishing point tends to be a little unnecessary, so we can represent most of our daily lives as two-point perspective. Two-point perspective scenes tend to be very different compositionally from one-point perspective. In most cases, the center of focus will not be where the vanishing points are. Two-point perspective relies more on the scale and placement of important elements within the scene to really have a center of focus stand out. Two-point perspective can also be rotated for vertically oriented scenes, where the horizon line is going from top to bottom instead of side to side. In such cases, the horizontal lines that make up the objects will be parallel this time instead of the vertical ones. When used this way, two-point perspective can be used for a looking up point of view, but only when we are completely perpendicular to the rest of the scene. Well, that about does it for two-point perspective. If you have any further questions, you can feel free to ask them in the Q&A section of the class. I'll be happy to answer anything you have there. And that said, I'll see you in the next video.